improved human lives. We have raised the standard of living for every person on Earth because of space exploration. We're going to go back to the moon, and we're going to take what we learned there, and we're going to go to Mars.
building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it today, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. Because we stand on the shoulders of giants to go farther than humanity has ever been. We will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this goal. We are NASA. And after 60 years, we're back in the start.
Woo! Now, everyone.
Of the country that all of us love. That's why NASA is a sponsor of this event. That's why NASA right now puts $4.1 million annually into FIRST Robotics, and we've been sponsoring this event since 1995. We provide mobile shops. We provide mentorships with engineering, and of course we provide dollars because you in this room future to look forward to. So he said, go to the moon sustainably with international partners, and we now have a coalition of nations on the International Space Station. We're talking about 15 countries collaborating and working in space now for 18 years. The high school student, yes, the high school students in this room. There has not been a day that you have been alive. could benefit from it, including when you think about the internet here in rural Oklahoma, we have internet broadband delivered from space commercially, born from this little agency that gets less than 1/2 of 1% of the federal budget. What an amazing accomplishment, but it's not just about communication. It's about navigation. People in this room are familiar with GPS. It's about the way we produce food. We're increasing crop yields now, reducing water usage, saving water, preserving nitrates in the soil. In fact, in Uganda in 2017, NASA was responsible for saving lives and mitigating a natural disaster, a drought. And in the course of that event, we saved the American taxpayer. Of the federal budget. Here's the thing, friends. When they started the Apollo program to go to the moon, nobody had any of this in mind. And yet here we are. And that's why we support this event. That's why we support FIRST Robotics. It is your generation that is going to take us to the next level, to the next step. And I want to go through for you just a few capabilities that we have ongoing right now. Anybody here interested in robots? We need to pull up a PowerPoint here. So we're going to do some exploration of space technology. The first robot I'm going to show you was actually 2 robots, Spirit and Opportunity. Anybody heard of Spirit and Opportunity? Two of these little robots were delivered to Mars back in 2004. We were just hopeful that they could last for 90 days and maybe make it 100 meters. That was the goal. And in fact, Spirit lasted until from 2004 to 2011, and Opportunity lasted until just about a month ago. What an amazing capability, born by NASA scientists, engineers, and robotics professionals. Now, because of Spirit and Opportunity, I want to share something with you. We learned some things. These 2 little robots demonstrated to us that there are minerals on Mars that can only exist underwater. Friends, Mars used to have water. Not just a little water. The entire northern hemisphere of Mars was 2/3 covered in ocean. We now know that there's evidence of flowing water. What does all of this mean? If it has water, liquid water on its surface, it also means that it had a thick atmosphere. It also means that it had a magnetosphere that protected it from the radiation of deep space. You put all this together and it says Mars was, at one time, habitable. I'm not saying it was inhabited, I don't know. So don't go tell the media that the NASA administrator said that there was bunny rabbits on Mars. But I will tell you that at one time in its history, 3 billion years ago, Mars was capable of hosting life. I'm not saying that it did, but it was capable. Okay, let's fast forward. Curiosity. Anybody familiar with Curiosity? Well, just since I've been the NASA administrator the last year, we have made amazing discoveries using this robot on Mars. We now know that there are complex organic compounds on the surface of Mars. Now that doesn't mean that there's life on Mars, but the probability just went up. The building blocks for life exist on Mars. I want to be clear. Those building blocks do not exist on the moon. They exist on Mars. And of course, they're all over planet Earth. And they exist on Mars in massive volumes. So there is something about Mars history that says the building blocks of life exist there now. What could have gone on in its history? We also know, because of curiosity, that the methane cycles of Mars are perfectly commensurate with the seasons of Mars. Again, that doesn't guarantee life, but the probability just went up a little bit more. And just a few months ago, we discovered, not with this spacecraft, but with some of our international partners, we discovered that there is liquid water 12 kilometers below the surface of Mars. Liquid water, friends. Anybody know anything about liquid water on Earth? Wherever there's liquid water, there's life. We now know there's liquid water 12 kilometers under the surface of Mars. What does that mean? That means that there is a potential, and I'm not saying there is, NASA makes no predictions until we make discoveries, but 12 kilometers under its surface means that water is protected from the deep space radiation that comes from the sun. Again, doesn't guarantee life, but the probability keeps going up. Who in this room wants to be the engineer that develops the robot, or even the astronaut who finds life on another world? Anybody here want to do that? Friends, that's what we're trying to achieve, and right now we are following the water. This is InSight. We landed InSight on Mars in November, and it was an amazing day. This is a key capability that I think is important in you as the future technicians and robotics engineers that you might want to consider. When we achieved something like this, we landed on Mars for the 8th time in human history. 8 times. The United States of America is the only country that's ever been able to do it. Others have tried and failed. We've done it. Now we're doing it with our international partners. All of the science and all the data that we get, we give to the world for free. Why? Because it's science. That's why. And here's the thing. And here's the thing. When we landed InSight on Mars, we also were on the cover of 240 newspapers worldwide. Friends, NASA is an amazing tool of diplomacy for the United States of America. So we're talking about children in countries on the other side of the planet that maybe aren't always so friendly to the United States, seeing NASA on the cover of their newspapers and shaping their perception of who we are in the United States. This is an amazing diplomatic capability and an amazing soft power capability. InSight looks a lot like Phoenix, which also was a discovery on Mars. 2009, we discovered pure water ice on the surface of Mars. Pure water ice on the surface of Mars. All robotics, friends. That's what we're here to do today. More robotics. Okay, Maven, we talked about how there was water on Mars. Where did it go? Well, a long time ago, and again, I don't know, I wasn't there, neither was anybody else, but a long time ago, it seems like Mars might have had a molten core, like the Earth has a molten core, and because of that, it had a magnetosphere that protected it from the radiation from the sun. Well, that core cooled. The magnetosphere went away. Charged particles from the sun impacted the planet, and a lot of that water went out into space. Again, we weren't there, but we're trying to make assessments as to what happened. And this satellite, Maven, which is robotic, remember, each of these satellites, they look like satellites, they're robots. They have to work autonomously. You know, it takes 8 minutes for the signal to come to Earth from Mars, which means what it does, it is often making decisions autonomously. And of course, this is a little satellite we call OSIRIS-REx. Over Christmas, OSIRIS-REx entered orbit around an asteroid called Thay in deep space. This robot, by the way, that's the first time in human history we've been able to orbit an object that small. But this robot is going to collect a sample from that that asteroid in deep space, and it's going to bring that sample back to Earth, and we're going to be able to use really large microscopes to look at that soil and make assessments as to the origins of our own solar system. Very exciting mission. It's coming home in 2021. Anybody here want to see the samples that come back in 2021? And here we have a satellite called Juno that is getting really up close and beautiful pictures of Jupiter. I'm going to accelerate here. Cassini. This is an amazing capability. Cassini was around Saturn for a long time, many years. And what it did at the end of its life, we determined that it was coming to the end of its life. It was almost out of fuel. And we were able to fly this little satellite between and through the rings of Saturn and really get amazing pictures. So I'd encourage all of you in high school, when you get home, go look at the amazing pictures from the Cassini